Hello, my name's Rob Steenburgh. I'm a forecaster and scientist from the Space Weather Prediction Center in Boulder, Colorado. And today I'm going to talk about whether an ionospheric scale would meet GNSS user needs and what form the scale should take. I'd like to thank the organizers for inviting me to speak and thank my colleague Tim Fuller-Rowell for his assistance in putting this together. We're lucky because this question about user needs is timely in that a survey of the GNSS community was conducted a couple of years ago as part of the Space Weather Operations Research and Mitigation activity that took place under the Office of Science and Technology Policy. So we are the beneficiaries of that information, and we'll use that today and apply it to this question. The survey was conducted by ABT Associates, and I'd like to acknowledge Olivia Griot and Dave Mills of that group for their contributions to this presentation. Slides that they produced as part of their report are integrated into this. So we'll look at some background about the survey, some specifics for the GNSS community, the overall results, and implications for an ionospheric scale. So some background, we went out and found 5 sectors that we thought were users of space weather information. And within those 5 sectors, we looked for 4 to 5 stakeholders with expertise in the application of space weather information to that particular sector. You can see above the sectors included the power industry and satellite industry, aviation, emergency management, and finally GNSS. Some key findings, beginning with the awareness of space weather impacts and the availability of information. The electric power grid probably placed the highest, and keep in mind these are relative and anecdotal measurements based on the interaction of the survey team with the participants. But the electric power industry was very tuned in. It makes sense given the impact that extreme geomagnetic storms can have on the electric grid. You can see GNSS fell closer to the bottom of the scale, and I attribute part of that to the wide variety of GNSS users and applications out there. As time goes on, the number of GNSS users as well as the applications for GNSS have increased tremendously, and consequently not everyone's going to be aware that space weather can even impact those systems. So some key findings overall across all the industries or sectors that were examined. They requested more spatially explicit information and forecasts. If you think about it right now, when the Space Weather Prediction Center issues a warning or alert, it's for the entire globe, typically. It's for Earth. And Earth is big, and people need more specific information for their particular location. Now, SWPC's made advances in the area of trying to provide more specific regional information for users. 2 examples, the first of which is the electric field product that has recently come online and is now available to the power industry. This product specifies electric field values across the continental US as well as portions of Canada. And this information is packaged in a way that it can be ingested by the power companies and used in their models of their particular grid to assess the vulnerability during space weather events. So that's one example. Prior to that, they'd been using the geomagnetic planetary K index, which was a global index, and they were doing their best to use that to inform their operational posturing during these events. The problem was it really didn't take into account the underlying surface geology, and that is important when you're talking about induced electric fields on power lines. Another example of spatially explicit information and forecasts includes our recent foray into providing space weather information for international civil aviation interests. ICAO, or the International Civil Aviation Organization, asked us to begin producing space weather information specifically for international aviation interests, and we're one of 4 centers worldwide that will be providing this information. As part of the requirements for that service, we have to specify either latitudinal bands where impacts occur, or polygons that specify areas on Earth that are affected. So this is again an example of moving towards more regionally specific forecasts and information. More lead time for warnings and notifications. That is a common request, and it's been there forever, really. But the more time in advance you know about a pending event, the more you can prepare and take actions to mitigate the impacts. Improved access to historical data, that's pretty self-explanatory, and we're working with our partner organization, the National Centers for Environmental Information, to satisfy that need. And then another one that I think pertains particularly to the idea of a ionospheric scale is a plain language impact-based products. As I mentioned, the awareness of space weather information and impacts in the GNSS community fell on the lower end of scale, and it really varies widely depending on the application and the level of knowledge of the person engaged in that activity. So the more we can make the products accessible to all users, the more likely we are to have an impact and improve their operations with respect to understanding and responding to space weather. And then finally, all clear notices refer to specifications or forecasts indicating a period of time when space weather would be benign to permit certain activities. For instance, an all-clear period might be specified so that astronauts can go on extravehicular activity outside the International Space Station to perform repairs. So they're not only interested in when things are going to happen, they're interested in windows of time when nothing is going to happen. So, in the course of the survey, the requests were kind of initially evaluated for their feasibility. The spatially explicit information and forecasts, initially when the survey was done, the feasibility was fairly low, but as I mentioned, we've got 2 areas now, support to the electric power industry and aviation, in which we're providing higher spatial and temporal resolution information. Improved lead time, that's really going to be a function of observations and modeling. The better our observational capabilities and modeling capabilities are, the more able we'll be to provide longer lead time. But there are limits just imposed by the nature of the problem as well. So right now the feasibility is fairly low. Access to historical data, that's a low-hanging fruit. That's something we can knock out, I think, relatively easily. From a technological standpoint, from an administrative standpoint, there are always hurdles to overcome, just like anything. Plain language impact-based products, that's huge. And I want to, I mentioned the importance of plain language in the earlier slide. I want to focus on impact-based on this slide because that's really the bottom line. For instance, the product that we put together for the international civil aviation community, specifying impacts for GNSS, for instance. We don't talk about S4 or sigma phi within the body of the product that we send to the end users, to the dispatchers and pilots who actually use this information, because they don't A, know what that is, and B, don't care. It's meaningless to them. They need to know what it means for their ability to navigate. So we'll send out advisories that indicate moderate to severe impacts on their GNSS capabilities. Now, in turn, the customers, the pilots in this case, have to understand what that particular advisory means to their operations. And that's going to be a function of the type of equipment they have, among many other things. So that's a real challenge. Impact-based products are a real challenge, but it has applicability when you're considering creating an ionospheric scale. And then the all-clear notices, as I mentioned earlier, those still present a considerable challenge. So for GNSS specific portion of the survey, there were 5 interviewees spanning operations and engineering, and the categories within that we targeted included position, navigation, and timing. The engineers were interested in real-time and historical data, while the operators were primarily interested in the alerts, which are considered real-time, as well as real-time products like the North American total electron content. Some product requests includes improved precision and granularity of forecasts, developing scintillation forecasts, and improving the accessibility and usability. So the precision and granularity we spoke about earlier. Scintillation forecasts, we're doing that now for the aviation community. We produce a rate of tech index, RODI product, that goes out to the, it goes into the forecast office, and the forecasters in turn interpret that product and issue advisories accordingly. That product's not yet available to the general public through our website, but we're looking into that. At first we have to evaluate this though and make sure that what we're putting out there is indeed useful and performing the service that we intend. And then finally, improving product accessibility and usability. There they were looking for non-expert language to translate space weather phenomena to potential impacts. So you'll see that theme again and again, and this is really the direction the Weather Service is going to. While forecasters in the past were primarily scientists engaged in specifying the particular atmospheric parameters in the future, be it wind speed or temperature and so on. Now the focus is shifting because the models can handle a lot of that fairly well. The focus is shifting to really taking that information and tailoring it to impacts for particular sectors of society and industry. Some more explicit information from the survey for GNSS. Scintillation requirements there include some nice spatial and temporal resolution requests. The accuracy of geomagnetic storm forecasts is there. GNSS specific warnings and nowcasts. We don't do that right now. Really, our users take the geomagnetic watches, warnings, and alerts as a proxy for ionospheric conditions. We talked about the geographies. Tools to translate space weather phenomena to impacts. I mentioned that on the previous slide. And then use by non-experts. And I think that's where an ionospheric index could really play a role. I Googled ionospheric index in the course of preparing this talk, and I came up with about 585 articles in Google Scholar when I searched on ionospheric index. So there's lots of interest out there. I looked over some of them, and you're going to hear some today. You'll hear discussions. In fact, this whole session is dedicated to that. So it's going to be pretty interesting. Some things to consider. Why are you doing it? What's the purpose of the index? Is it characterization? Is it for nowcasting? Is it for forecasting? Who's the audience? Is it research? Is it operations? Is it both? If it's both, is the information that you're going to present accessible and usable? And can you tie an atmospheric index or an ionospheric index or scale to the impacts? Because that's going to be the bottom line. And we won't be able to, I don't think as a community we'll be able to do that in isolation. This is going to involve interaction with the end users, and they're going to have to build an understanding for their particular systems and applications of what a particular value of an index or scale means in terms of timing, along with timing, magnitude, duration, and localization, which we mentioned earlier. And then finally, a couple other things to think about marketing. Once you have an index or scale, how do you get the word out? How do you get the word out to the GNSS community that this is a thing and it's a thing they can use? And then how do you implement it? What does a product look like that serves this community? Do we include it in routine forecasts every 12 hours? Is it an alert-based or hazard-based product that goes out when driven by events? These are the kinds of questions that are kind of wide open right now. An additional resource you might find interesting is a report on the economic impacts of space weather in the U.S. This, in conjunction with the user needs survey, can give you a great lay of the land in terms of what's out there for the future. All right, I'll leave a little bit of time for questions. Again, I'd like to thank everyone. And if you have questions, my contact information is on the slide. Thank you very much.